Good afternoon, Year 10s. Thanks for coming along, guys. We are finishing off our very last lesson on electrolysis, and we are doing lesson 3 today. Oh, I'm just going to pause my other computer. There we go. Get rid of that. I'll pop out the chat. I love the fact that Jack just cannot make it onto the chat first. It is hilarious. I love it, Jack. It just makes my day. Absolutely brilliant. So today's lesson is the last lesson of electrolysis. I'll bring up my things here, and this is electrolysis, GCSE Electrolysis lesson 3. Lesson 3. And it is actually aqueous part 2. Aqueous part 2. And I'm going to be linking this heavily today to practicals. So 3 learning objectives. I love that. Go Callista. I love it. Okay, today's like goal 10. Oh, I like goal. Oh, Jack, you are just brilliant. Go Callista. I shouldn't laugh, but it's brilliant. Oh, okay. I'll share my screen, guys, and bring you guys into the fold. Okay, let's do it. So, there we go. We're up and running. So, there's our learning objectives for the day. I'm going to switch my tablet to tablet mode. There we go. Turn on my little fan, keep it cool. So we've got 3 learning objectives today, guys. Number 1, you guys need to know what a Hoffman voltameter is. Now, just to actually tell you that the Hoffman is actually split into 2 varieties, which is kind of wonky. So there's a Hoffman voltameter, and there's 2 types. Almost there. 3 more. Love you guys. So the Hoffman voltameter, there is the big one. I know, right? I know. And there is also a small one. Now, the small one is the practical one that you guys are going to have to use when we do get back into school. We're going to be doing all of these practicals for you guys to actually have a look at these and see them. But today we need to make sure we understand and know the Hoffman voltameter. Then the second one is know the observations with indicator. Now that is linked again to the Hoffman. By the way, I often call it a baby Hoffman with the small one. I often call it a baby Hoffman, or sometimes called an electrolysis cell. I'm actually just going to put that underneath this. So this is sometimes referred to as an electrolysis cell. I know, go figure. Next, the third learning objective is understand the electrolysis of sulfuric acid and copper sulfate. Amazing. And this one is linked to plating. Yeah. By the way, I'm going to give that properly, which is electroplating. Once again, all practicals. Electroplating. I like it. Okay. So the first thing I need to do is I need to introduce you guys to the Hoffman. Oh, the joys of the Hoffman. I've got some exam questions, by the way, that I'm going to do at the end of the lesson. But I need to show you guys a Hoffman voltameter. Hello. Images. There we go. And there is a Hoffman. Look at that. Isn't that a really pretty piece of equipment? There we go. I'm going to borrow you. Yellow. Copy. This is the big one. I always love that. This is a genuine. This is the big. I'm gonna go, and I'm gonna go the big Hoffman. And it's actually capital H because it was named after the guy. Hoffman voltameter. So this piece of equipment was designed and built. Yeah, we did it. 10 likes. Amazing. Right, La Past. Now, you guys can find a picture of this on the internet as well, and you can either print it off and stick it into your books or attach it to your digital notes if you're keeping digital notes. But it's a really beautiful piece of equipment. And we've got 2 of them in school, amazingly. I know, right? And they're really beautiful pieces of equipment. So it's a rather cool thing. So what it is, very straightforward. It is a glass tube. If I draw this out, it is a glass tube. It's got a funky bulb at the top. And then it splits at the bottom at a T-junction. And then you have these 2 other vertical tubes Done a terrible job of that. I can't get that song out of my head now. It's amazing. There we go. There we go. That's better. It's a terrible. I'm gonna redo that cork. So now the function of the Hoffman. There we go. And at this point, you hook this up to a battery. Yep. It's nice to remind ourselves that the long stick in the battery picture is the positive, and the negative is the short one. And what we do, these, by the way, then go to taps. These go to little taps. There's a tap there and a tap here. Now, what we do is we fill the Hoffman with a solution that we want to electrolyze. So, for example, we're going to pour into the top of this sodium chloride solution. And once again, you can't, this is never going to be molten because you'd melt the glass. Yeah, we're going to be doing this, and it would also solidify and just block the tubes anyway. So we're going to be adding a solution of salt water. Now the solution fills up to these lines. So I'm going to now highlight this if I can. Whoa, that's a bit big. Undo. Let's make that a bit smaller. Right, so it fills up. You then fill it up with this, with brine. Brine is, we now know that brine is the common name for salt water. So we fill this up with the solution. Now remember, the solution is actually colorless. The solution is colorless. I'm sorry that this is taking me so long. There we go, and it stops at the tap. Stops at the tap. There we go. Getting there slowly. There we go. And then it's actually easier if I do like a little zigzaggy pattern. So the solution fills this up. Now what we next do is we now have at the bottom, we've got our by the way, at this point I'm going to introduce you to a new word. So the word electrolyte. Electrolyte. The word electrolyte translates to a liquid or solution that conducts electricity. Conducts electricity. There we go. So this could be, this could be sodium chloride liquid or molten. Yeah, molten. And that would be a glowing orange liquid, scary stuff, 800 degrees Celsius, 801 degrees Celsius. Or it could be sodium chloride aqueous. We realize that molten ionics conduct, but also solution ionics conduct as well. So these are electrolytes. So we filled the solution with the electrolyte. I'm going to get rid of all this now. And then what we've done is, so the electrolyte, of course, is the liquid. So now what we're going to do is, we've now got at the bottom some electrodes, and we can start naming our electrodes. So we can color code this. Here's the red electrode. Now the red electrode is hooked up to the positive. Now Zyno has just taught me one of the most amazing tricks, which I have never ever thought about, but I love this one. This electrode, oh no, that's the problem. Yeah, this is a problem. This is the anode. Yeah, this is the anode. And the reason why this is the anode, I'll write it in red to carry on with the link. This is the anode. It's called the anode because it attracts anions. And we remember panic. Positive anode, negative cathode. Yeah, love panic. So there's the anode. I'm going to color code the other guy here. This guy here. This one's hooked up to the positive. Sorry, to the negative. So negative cathode. So here's the cathode. Okay. So we know that this solution is going to conduct electricity. What we now do is we now add universal indicator. Now, universal indicator in salt water is green. Now, the reason for this is because the salt solutions are neutral. So technically, I shouldn't really have colored this in. What I should have done, oh dear, we're going to add universal indicator, and the whole thing is going to turn green. I'm just going to do it like this. Yeah, because the salt water is neutral. Now, the next thing is what's going to happen, this is universal indicator. So we can add this to our notes. Add universal indicator. Universal indicator. Right, so the universal indicator will turn green. Turn green in salt water. Salt water. It's nice to link this to year 7. Let's have a look at the pH range, and we need this at GCSE. We need this all the way through. pH indicator scale. Let's have a look. And there we go. Perfect. Perfect. So we've got green, pH 7. I like it a lot. I'm going to steal that. Yoink. No, I'm not. Yes, I am. I'm going to yoink that one. And I'm going to put that right underneath. Now, and as like you said, you guys can do the same thing. It's useful to be able to do this, isn't it? So we've now got green pH 7 salt water. Now we're going to switch on the power pack. Now we need to know brine, the electrolysis of brine. We know that it's special and it's done on an industrial scale. So the electrolysis, I'm going to put this in this is a very important box. Electrolysis of brine. We make 3 products. Products. Number 1, we make chlorine gas. Chlorine gas. Let's show the half equation for that. So the chloride ion in aqueous is going to have its electrons ripped off it, and it's going to become chlorine. So there's the half equation for that guy. And that there is an anion, yeah, because it's a negative negative ion, yeah, a negative ion. So we're going to form chlorine gas. Now, what uses do we have for chlorine gas? So number 1 is we need to know that it's a green gas. It is a green gas, and the top uses, the uses for these are number 1, sterilize water. Sterilize water. You guys drink this every day. Kills the bacteria. Number 2, it's used to make PVC plastic. Used to make PVC. Number 3, what other uses of chlorine are there? For making hydrochloric acid. Make HCl. I'll put underneath that hydrochloric acid. I like it. Hippity hoppity, the image is now my property. Jackie, you okay? Are you feeling all right? Anyway, so we've made chlorine gas. Very useful, used all around the world. Great stuff. Product number 2 is hydrogen. We love hydrogen. Let's have a look at the half equation. The H plus from water, we learned that last lesson. Yeah, the H plus from water gains 2 electrons, and becomes hydrogen gas. So this is happening. This is the cation. Do you see Zaina's little thing there? Zaina, I love that. I think that's ace. Really love it. A cation is positive because the T looks like a plus at the top. Also looks like it's religious. So the cations gain electrons, and then we can link these to oxidation and reduction if we like. Yeah, oxidation is the loss. Let's go blue. Oxidation is loss. There's loss. That's oxidation. Yeah, and then this one is over here, change my color. This one here is gaining, gain. So that's reduction. Okay, right. Oxidation and reduction. I love oil rig, makes me so happy. Right, product number 3. Oh, sorry, uses. Oh, can't miss it. Hydrogen uses. It's used, number one, as a fuel. As a fuel. We burn it to make electricity and to move cars and spaceships. Number two, it is used to make ammonia NH3. Just to show you that, ammonia is nitrogen plus hydrogen in equilibrium, a reversible reaction to produce ammonia, and we can then balance that one as well. So the hydrogen here comes from the electrolysis of brine, of seawater. The pH scale image you stole, that was a joke. Okay, all right, Jack. I think Jack's lost his mind. Yeah, resource, electrolysis of brine. Electrolysis of brine, that's where we make it. And we use this on a massive scale, by the way. If you want another one, if you want another use, you could also say used for hydrogenation to turn vegetable oil into margarine, but I don't think we need to. Those are the top two. Let's stick with those. It's nice to mention as well, nota bene on hydrogen, do it in red. It's nice to constantly reinforce good data. Yeah, problem with hydrogen, problem with H2 is it's explosive. Yeah, we do love hydrogen for that. I demonstrated that in class where I blew up the Pringles can. It was amazing, wasn't it? Absolutely loved it. Product number three. Yeah, product number three. Change my pen back to black. Zoom, zoom. Product number three is sodium hydroxide. Now, sodium hydroxide, and I'm going to underline the hydroxide. I just love the fact that we can now build all these formulas. NaOH. This is a byproduct. This is just left behind. Yeah, and any hydroxide is an alkali. Okay, now the reason why this is important is because we then come to the Hoffman, because we see something rather cool happen in this. So here's what we're going to see. Oh no. Okay, what I'm going to do is I'm going to do it on this one. Right, and look, we've even got the charges on these and everything. So we've got the positive electrode panic. Positive anode, yeah, negative cathode. So that's the cathode. And what we realize, the negative one is going to attract the positive ions. So in here, we know that the hydrogen ions, the H plus ions from water, are going to make their way over to here. And what's going to happen is they're going to turn into hydrogen gas, and they're going to fill the tube up, and there's going to become a gap. Yeah, at the top of here, we're going to build up hydrogen gas, H2 gas. My laptop is roasting red hot, my fan's wandering away. So that one fills up with hydrogen gas. The cathode attracts cations. On the opposite side, I shouldn't be doing it in purple, by the way, black. There you go, and we're going to form a hydrogen gas. H2. On this side, the chloride ion is going to accumulate at this electrode, and it's going to become a gas as well. And that's going to become chlorine. And the chlorine is also going to fill up the tube. However, there's a rather interesting observation here, which is you tend to make more hydrogen than you do chlorine. And I'll explain that now. So number one is you tend to see a slight greeny color over here. Very slight, not by much. And also, the green tube gets bleached. You can actually add this, because this is actually one of the tests for chlorine gas. We can add this as to a note on chlorine. So chlorine is actually used to make bleach as well. It's not one that I actually want you to use, though, but it's true. But what happens is the tube changes color. At the beginning, it was all green. And then here's what it becomes. I shouldn't do that one in purple. There's the hydrogen gas now. It's now empty up there, but full of hydrogen gas. And this tube turns purple. Yeah, it actually tends to go across to about there. The central tube remains green. The central tube remains green. Yeah, like that. And then this tube goes like a funny off-white color. It actually goes a funny off-white. See if I can find it. It goes like this kind of color. This one Oh, that didn't work. Oh yeah, well, that's the thing, is it does that. It was green before, and now it becomes like an off yellow. And the reason being is the chlorine is bleaching it. And the sodium hydroxide, which is building up over here because the sodium ions are building up on this side, and you tend to accumulate on this side, yeah, we tend to form these rather interesting. The purple color actually ends up spreading, but the thing is, it doesn't ever get very far on here because it gets bleached. So it looks like that. So you end up with left behind in the water the sodium hydroxide, which is purple because it's an alkali, yeah, and the chlorine bleaches it. So you get these rather bizarre observations. The next observation is this one. You tend to get twice as much hydrogen as you do chlorine. Now, this is very odd. It's not expected, this. You're meant to get exactly the same quantity. Because both of them required 2 electrons, we should get exactly the same. Those equations go together. And we should get exactly the same amount. However, we see less chlorine. And the reason why we see less chlorine is it dissolves. It dissolves into the water. Like the swimming pool, into the water. The hydrogen doesn't, but the chlorine does. So the water then smells like chlorine. And you can do this. As I said, we do this as a class practical, where you guys all get to do this. And then you can test each of the gases. And we're going to come to gas testing in our next lesson. So these observations are ones that you have to be able to do. I'm going to show you the baby Hoffman now. Check out the baby Hoffman. Yeah, baby Hoffman. If I type in baby Hoffman, it's not going to work. Baby Hoffman voltameter. I knew that was going to happen. Hoffman voltameter. If I do electrolysis cell, it'll probably come up. I may have to join. Let's do electrolysis cell voltameter. Let's try that. Come on, give me what I want. Let's do, if I add on to there, electrolysis cell beaker. That might work. There. Oh, it's not a great one, actually. It's a bit disappointing. I'm going to have to draw it for you. You guys usually use these in school, you see. I really want to find, there should be, I don't see why it should be so hard to find. It's really not what I want either. It's giving me loads of stuff I don't want. Electrolysis beaker. Let's try that. Ah, there it is. Or something similar. There you go. So you can do this on a small scale. Can you guess which one of those is hydrogen, which one of those is chlorine? Yeah, so the large one over here, that's going to be hydrogen because it's not soluble. And this one's going to be the chlorine because it's dissolving into the water. They haven't bothered to add any indicators in this. Oh, there's a better one. Prefer that one. But it's an animation version. It's not a real one. Am I going to find anything else? I'm going to draw it for you. There's one. The ones in school that we have are better. And I'll draw that out for you. So here's the baby Hoffman. Zoom, zoom. Okay. So this is the electrolysis practical. I may actually be able to link this to an exam question as well. So here's what you do in class. We have a very special thing, which is the electrolysis cell beaker. And it's a rather odd looking device because it has holes at the bottom. I'm doing a great job drawing this beaker. There we go. And there are holes at the bottom. Now, what you do is, this is where your electrodes are going to go. So this is the electrolysis beaker. And what we then do is we put corks in, which contain our electrodes. Now, the electrodes are made out of graphite. It's cheap, good conductor of electricity, and inert. So I add in my electrodes, and we've corked it. As I said, you usually do this in class. That then you can hook up here, so we can add graphite electrodes. You can draw this in your books. Graphite electrodes. And we're now going to fill this up with an electrolyte, and we're going to add brine. We're going to add sodium chloride aqueous. Okay, we can hook this up to a battery, some crocodile clips. Trying to do an amazing little drawing here. There we go, crocodile clip number 1. And then crocodile clip number 2. There we go. And we're going to hook that up to a battery. There we go. We're also going to add a light bulb. I have to say, I always like a light bulb in this circuit because it tells me when it's working. Yep, there we go. Now, as soon as that happens, we know that this one here is the positive electrode. Yeah, panic, positive anode. So this is the anode, yeah, which is positive due to panic. And this is negative, which is the cathode. Now, what we can do is we can now see the fact that both of these are going to start bubbling. They're going to start producing bubbles. I'll send you the video of this, but then we're going to have a go at this. They're going to start producing bubbles from the electrodes. Yeah. Now, if you add universal indicator to the beaker goes orange. Sorry, orange. The beaker goes green. Yeah, you get a nice green color at the beginning. That's rubbish. I don't like it. Change my mind. So it goes green at the beginning. Now, the cathode is going to attract the H pluses. So on this side, H plus is going to go, and I'm going to form hydrogen gas bubbles. Now, these will just bubble away, but we're going to collect them. We're going to do a clever trick there to collect it. On this side, the chloride ions go to it. So we're going to get chlorine gas. Now, the chlorine gas, of course, is going to dissolve into the water. So how do we collect them? We do a really clever little trick. You just take 2 test tubes. And what you do is you put the test tubes over the top of them, like this. You put a test tube over the top of them. And what happens is, this is where I need to now edit that, and the test tubes we fill with the solution as well. So what now happens is the chlorine builds up here. So the chlorine is displacing the fluid. The chlorine builds up here, and over here we have more hydrogen. As it displaces it, the hydrogen builds up here. There we go. And we get to see the chlorine test tube gets bleached. The chlorine test tube gets bleached. Yeah, the hydrogen does absolutely nothing. But then we tend to see the green appear over here because the hydrogen's not really doing much. But then at the bottom of the beaker starts to fill up with purple because we're making, as a byproduct, sodium hydroxide. It's a really cool practical, and it works so well. It's a beautiful practical. And it goes purple because it's alkali. Any hydroxide, yeah, what makes an alkali an alkali is OH minus. Yeah, I won't bother circling it. That ion, I'm going to make that bigger. That ion, OH minus, is what makes an alkali an alkali. Yeah. So you have this really lovely thing. And then, of course, you can test the hydrogen, you light it, and you get a beautiful squeaky pop. Yeah, it's a really lovely thing that. It works really, really well. I want to see if I can show you this as an exam question. Let's do, what would it be under? Oh, I can't remember what year it was. Electrolysis exam question. Don't think that's going to work, is it? There's one where they gave you all the parts and you had to piece it together. It was ridiculous. I've never seen one like it before, but it was quite a funky one. Look, they're giving you these cells. There you go. There's the beaker with the cork at the bottom. Getting lots of these. Yeah, all the same thing. Predicting which is going to be where. Yeah, all good stuff. And we can predict who's going to be where, which is quite nice, based on the different volumes. That's interesting, isn't it? Look at that. Same things. Test yourself. I really want to find the question where you had to build it. And they gave you all the parts. Oh, I'll add it to the worksheet for you guys to have a go at. Because it was quite a good question, if I'm honest. I quite liked it. Yeah, anyway, let's move on. Let's move on. So this little practical is a rather lovely one. And as I said, it comes up very, very regularly. So I can tick off the Hoffman and the observations with the indicator. Key thing, chlorine bleaches, the sodium hydroxide turns it purple, and those are the only 2. Right, now we need to talk about the electrolysis of sulfuric acid. So what we're going to do is we're going to do exactly the same setup. This was a brine setup. This is brine. Yeah. Let's do exactly the same thing, but this time let's do sulfuric acid. So let's do the electrolysis, as I said, very much from a practical standpoint, of sulfuric acid. Right. So sulfuric acid, let's draw the beaker with the holes in the bottom. There we go. Not the best one I've ever done. There we go. I'm going to add in my electrodes. Add in my electrodes. That'll do. Doesn't really matter, to be fair. There we go. And we fill this up with H2SO4. Now, here's the thing with H2SO4. When you haven't learned about acids properly yet, but when you take any acid and you add it to water, it actually breaks apart. It breaks apart to give you these guys. Now, what we also have in the beaker is water. Now, water, we know from last lesson, breaks apart itself to give us more H pluses and an OH minus ion. Now, what that now means is when we now run electrolysis, so this is the positive, that's the negative. Right, what's going to happen is at the positive electrode, these guys will go to the positive electrode. But just like in the just like with the Cl versus the OH minus, the simpler one of the two ions gets electrolyzed, and that's the OH minus, and the OH minus becomes oxygen. So what we get is two products from the electrolysis of this acid. We get hydrogen. Surprise, surprise. It's the only positive ion we have. Those positive ions make it to the negative electrode, and they turn into hydrogen gas. Two of them hit it, they gain 2 electrons, and they become a hydrogen gas, and we get loads of it. But on the other side, we have the OH minus ion, and the OH minus ion becomes oxygen, and then I need to balance it in some regard, which is an absolute nightmare, and then I need 4 of those. I told you had to learn this, plus 4 electrons. I think that works out, does it not? 4 O's, 2, 4 O's, 4 H's, 4 H's there, 4 H's there. I like it. And then balance for charge. So we got 4 minuses there. So we need 4 electrons on that side. So it can be done. So we form. Now the key thing here is what you notice is that there are 4 electrons here and only 2 electrons here. What that means is you can't have that. You can't have unbalanced electrons. So what's going to happen is the hydrogen one is going to get run twice so that the electrons cancel. And no, this is hard. I don't want you guys to get too worried about this, because in reality, it's not actually like as hard as it seems. Right, what that means is for every 4 electrons, the the power pack pumps, I'm going to get 2 hydrogens and 1 oxygen. So if I collect these now, if I collected them, what I would notice is that I'm going to get twice as much hydrogen as I do oxygen, because the equations say I'm going to make twice as much, because there's a 2 there and an invisible 1 there. I know that's really hard. This is on your specification specifically. I thought I'd show you your spec today. Wrong one. Oh no, wrong one. Wrong one. I've changed it. I've lost it. GCSE Edexcel chemistry specification. I know that we're running out of time. My way. Oh, wink it. I know they don't even know that yet. So on the electrolysis section, it specifically says, which is there? No, have I gone past it? There's a box with a double thing on it. There. Is it there? Is that it? Yes. And it specifically says here that you need to know the products of, it's in 1.58C. Sodium chloride, we've done. Lead bromide, we've done. Now we're doing the dilute sulfuric acid. So we're going to form hydrogen and oxygen in a 2-to-1 ratio. That's all we really need, to be fair. So it's something to consider. I know that's hard. You'll see the exam questions, and it's nowhere near as hard as this. The reason being is they tend to give you these half written, and then you just kind of fill in the blanks. Yeah, but this is probably the highest level that you guys have studied with me. This is level 9, this stuff. This is really hard. But like I said, the questions are actually slightly easier because they're kind of half done for you. The last bit of plating, electroplating. Okay, so since we've discovered that we can move ions around, we discovered we could do some rather neat tricks. So we can take our beaker. Now let's say you have yourself a silver key. A silver key. Now what you want to do is cover that silver key. I'm going to color code this. Oh, blimey. I've zoomed right out, I believe. Uh-oh. Not that it really matters. I want to coat this silver key in copper. If I want to coat something, so electroplating, this process is used to plate metals in other metals. Now, I know that seems odd, but this is a form of protection. We know that iron rusts, so we quite often plate other metals on top of the iron, things like nickel or zinc, very commonly. And you can use electroplating. You might also plate things in gold. Jewelry, of course, is plated in gold. So if we want to cover that in another metal like copper, we're going to do a sneaky trick. We're going to have a second electrode. Don't really care. We can actually make that a source of copper if we like. Oh dear, this is going to get complicated very quickly. So I'm going to add an electrode here. And what I want to do is I need to fill the beaker with an electrolyte that contains copper. So I'm going to choose something like copper sulfate, aqueous. I'm going to take copper sulfate, which is blue, and the blue ions, of course, are the copper 2+, and then the sulfates are invisible. Got these 2 ions like that. I'm going to make that blue a bit thicker. There we go. And what I'm going to do is I want the copper to go over to that metal key. So what I do is I link it in a circuit, and I make it the negative ion, the negative electrode. Sorry, negative electrode. And if that's the negative electrode, the copper, we can zoom in now here. Yeah, so if we zoom in, what we see is happening. What's happening here is the key surface. Yeah, there's a key. The key surface have the blue copper ions are going to be attracted over towards the key's surface. Now, when they hit the surface, they're going to gain back their electrons and become copper metal. It's going to gain back 2 electrons. And what I'll do is I will cover the surface. I should make that smaller, really. Yeah, I'm going to cover the surface of that key in copper atoms. And so it now becomes covered in a copper layer. Every time an ion strikes the metal, it will gain back its electrons and turn back into copper metal. So the copper ions, which were blue, have come along. I know that the size is wrong, but it doesn't matter. But what happens is it strikes the key's surface and you form a pink metal. So just to show you this, so copper electrolysis plating. Images. Electroless plating, nice. Let's just put electroplating, that'll be better. Images. Right, and there you go. He's done exactly what I've said. He's taken his key, put it in, and he's now formed a layer of pink metal on the surface. I wonder, is lots of people using keys? We tend to use keys or coins in school. There you go. It's coated that one in copper there. It's not a great covering, is it? He's done it too quickly. But you can see the objects that they've plated. It's not particularly smooth, but you've certainly got your beautiful pink copper metal on the surface. It's a really nice thing to do this. And as I said, we often plate things in school for fun because you can take them home and make them pretty. You can. So at this point, I've got 5 minutes left. Just want to have a look at some exam questions. Okay, come on, clean up. There you go. So the first thing it's asking you to do is to balance half equations. So there are 2 bromines here. I'm going to need to balance that, and then with 2 electrons. And then B, 1 potassium, 1 electron, 1 potassium. That all adds up because the potassium's the K's of 1K, and it's gone from +1 to 0. And there's the 1 minus. So that one is already balanced. That's nice. Next one, we've got 1 aluminium and 1 aluminium. That's okay. Balance for atoms, balance for charge. 3 plus, 1 minus. That's not going to work. I'm going to attract 3 electrons, and I'm done. Next, at 1 O, 2 O's. Balance it. Right, now we balance for charge. 2 minuses. 4 minus on that side. And then we need 4 minuses on this side. So we're going to add the 4 in front of the electrons. It just takes practice. I know this is hard, folks. I really do. Like as I said, this is a tough one. Next, they're going to plate it in silver. The steel fork was placed in a solution containing silver ions. So the electrolyte contains silver something, probably something like silver nitrate. And then it says, after a few minutes, the forks were coated with a layer of silver. What was the fork the positive or negative electrode? Right. Well, we've got silver ions. Metal's always positive. We want him to move towards the fork. We'll make him the negative electrode. Yeah, panic. Positive anode, negative cathode. So that's going to be the cathode. Write an equation for the reaction that takes place at the positive electrode. Oh, the positive electrode. Oh. Do you notice what's happening? They've put in silver at the other side. Now, they've done something really clever here, guys. So, do you notice that they've put in a bar of silver? Here's a bar of silver. Well, something really clever is going to happen here. Because what's going to happen is the silver on the electrode is going to break away. This silver here is going to break off and form silver ions. And then the silver ions are going to move over there, collect their electrons, and become silver again. I haven't got time to go through all this. We need to do plating again properly and purifying as well. We're going to need a third one. Okay. Okay, guys. I'll end the electrolysis lesson there. So next lesson, I will do one more on plating. One more of plating and purifying. So we've ticked off sulfuric acid, just need to do electroplating next lesson, and we're done. So I'm going to end the lesson there today. I'll send you the worksheet to have a look at. Electrolysis is really tough. It's one of the hardest things I'll ever teach you. And it is difficult to wrap your head around. It just takes a bit of practice. You've just got to see the questions. Right, I'm going to leave you be there, guys. I hope you found it useful. I'll set you the questions that you can now access already. So I'll give you all the aqueous ones with the Hoffman. And then that way we can then focus specifically then on the electroplating next time. I'll see you guys next lesson. See you later.